My name is Mark Anderson. I'm the manager of the Manufacturing Solutions Group, or COE, Center of Excellence at Saratech. We're broken down into centers of excellence. We have one for each discipline, PLM, analysis, CAD, CAM, CMM, quality. What I'm going to be doing is I'm going to be giving you, there's so much data that we're going to be talking about, and there's going to be a ton of questions that you guys have for your own intimate areas of manufacturing and what applies to you. So what I'm doing is I'm just going to give you a high level overview of a digital thread, a real life digital thread that Saratech has completed for a customer. And it's going to go through the ideology of what a digital thread is. And then I have some presentations or some demonstrations in NX to show you guys. What I'm going to be showing you first is where we find ourselves today. So what I found in industry, I've been in this industry for about 30 years. I'm 46, so it's all I've done since I was 16 years old. I've been through vocational school, my BSME, and I have 2 journeyman's cards, one for machining and one for tool and die. So I've done this quite a lot, and I've been in a lot of companies. And what I found is that everybody comes into NX with some past experience, whether that's Mastercam, GibbsCam, WorkNC, something. Every one of those softwares are based in principle for themselves. They don't care about any type of CAD information. Very few of them even have step 242 converters that can bring in any type of product manufacturing information or any type of annotations that are meaningful to us in CAM. So what we do is we end up redoing things. So what you find yourself doing is the same thing in Mastercam that you're now trying to make work in NX. And NX is very capable of doing that, but you're doing yourself a disservice by not using it the way that NX was intended, which is we're always consuming data from downstream. So where CAD implements all the data that they possibly can so that we can consume it in CAM, consume it in CMM. So what I'm showing you today is generally the way that everybody uses NX from a perspective other than being taught within the NX environment and learning all the best practices. The next session that we're going to have is we're going to take all of what I show you today and the benefits of using NX in a non-managed environment with best practice principles. Then we're going to show what does that look like in a managed environment? What does that look like within the Teamcenter PLM product? And how does that affect us, and what does that provide for us, or how does that hinder us? So that'll be next session. So this current storyline, the customer product that they sent us, it's a rotary vane actuator for the rear end of an airplane, like a Cessna. It's activating the rear vane. So when they originally designed this, the criteria that they designed it with is in the center. So we have 7 newtons of force, kilonewtons of force. It's taking a lot of force. So they were seeing in the field anomalous breaks in those ears at that 50,000 thread radius. So they came to us and they said, well, what can we do to make this to where it's robust and we don't have any failures? So first thing that we did is we brought the part in and we made many different iterations in SimCenter. And then we put different forces on it and applied different directional forces. And we found that by increasing the radius to 125, we didn't see the ears breaking anymore, but it propagated the break to the hole. So the thin areas there at the hole was the now break point. So then we continued running through FEA analysis iterations, and we found that if we enlarge the within the ears of that by just 35 thousandths, we'll be able to maintain no breaking in that point. So at this point, we have a past FEA simulation that this part will actually meet the requirements that it was designed for. So instead of us just giving this back to the customer and saying, here, you guys go ahead and take this part now, make it in Mastercam, check it with PCDMIS and the CMM, give us the opportunity to run it through this Saratech digital thread. At Saratech, part of my organization is contract programming. So we do that in all different softwares, Mastercam, WorkNC, Creo. It doesn't matter. We have programmers that can do it, but the main product is NX. So what we've done over the last decade is we've taken all the different things that we wanted to do as programmers and we've templatized them. We've created functions, automation, and we've built what's called a true digital thread that's start to end within a single platform that's fully associative. So it's easy to say that, and then people perceive that their current system with SolidWorks and Windchill and all their different pieces is a digital thread as long as it's managed within an environment. But that's not correct. It has to be associative. The only product on the marketplace that can actually run a true digital thread is the Siemens products. So what we did is we ran it through the specific digital thread for component manufacturing that has very specific machine tools, fixtures, tooling, depth of cut, speeds, feeds, different parameters. But more than that, it has very sophisticated customization in it. Some of it is feature-based manufacturing. Some of it is instancing, where we've taken a specific logic that we can apply to all parts. In essence, if I have material, titanium material, my parts go from this big to this big, and my stock is basic shape. I can just make an instance of a roughing strategy that I can go from stock to near net and just apply it to every single part just by clicking on something and dragging it onto the screen. So it's highly customized and highly templatized. We can process parts very quickly and very accurately. So what does that look like from a high level perspective? This is the physical processing of this digital thread. We first took the customer data, we converted it into NX files because it did come to us in an outside format. Excuse me. Then we went through our design iterations, our FEA analysis. We initially got a failure. Iteration B succeeded, passed our FEA analysis requirements. So then this is where things diverge between current processes and working within a digital thread. So currently, most people do not use what's called NX stage models. They do some internal methodology of wave geometry linking or many different 6 of one, half dozen other methodologies to be able to get some representation of your after op one stock. So what does that do for us, and how does that hinder us from a programming perspective? If we don't have a direct representation, it's causing us to have to go in and manually manipulate parameters within the operation. Not this depth, but that depth. Don't hit the vise. Leave a 1/4 inch hat on the bottom of the part. But when I flip that part over on my secondary operation, I don't have a direct representation of that. If I wanted to take that part and I wanted to go to the CMM and inspect it before I did operation 2, I don't have a realistic part to be able to do that. So that's going to cause a downstream process of having to create a CMM program for this part. So there's a lot of different pieces to it that your current process, it's minutia of manufacturing in a non-managed environment. It's just how you do it. And all of those things that take a lot of time and are wasteful is just a part of the process that everybody just accepts. But there is a better way. There's a way that we can use this software to where we don't have to do a lot. We can use the automation that's built within without any type of customization to do something like 40% more efficient programming, just using the software out of the box the way it is in a non-managed environment. Some of that is doing things like creating your stage modeling, creating a direct digital twin of every single stage iteration. But moreover, you have no management in this. So if one person has this Lang vise and they've made a few modifications to it, and what happens if they accidentally made it off of center of its base? Then they go and put it into a simulation kit and everything runs different than in real life because that vise is not managed. It's not been approved. Everything has been ironed out and it's not in place to where people can then just use it. Everybody has the capability of having their own version of it. A lot of things can happen with that. For instance, cutting the wrong revision of a part. That's very indicative of working in a non-managed environment. Using a fixture that was meant for a previous revision. That's very indicative of working in a non-managed environment. Having to go out and find things in a network, spending a lot of time in organization and processing of your particular parts and keeping things organized, that's indicative of a non-managed environment. So in a managed environment, all of those things are in a system, a repository that's been approved, and then you just pull from it. Everybody has the same inner workings. And I'll show that in great detail next session. So processing through this digital thread, instead of just going at programming, saying, here's my part, here's my blank, I went through and I created the stage models. This is my operation 1 representation, operation 2 representation. What does that do for me? It makes it to where I can just do things like adaptive roughing, generate. Cavity mill, generate. Rest milling, generate. I don't have to go in and mess with the parameters. Where's my cut levels? The system understands it. So the process that we're talking about on the bottom left here, that's held in the vise. I could machine that part 100% without touching anything, without selecting the part, without doing anything. I would just utilize feature-based manufacturing, and then all of our operations are volumetric. I tell it that the vise is a check surface. I tell it what a clearance plane that I have, and then I just tell it to do it. It'll go stock to finished part, missing the vise. So you're using the intelligence of the software instead of us going in there each operation and manually making things as we see it. That's another area where there's inefficiencies utilizing NX's comparison to other softwares. With other softwares, you have to physically sit down and these are the tools that I'm going to use. This is the way I'm going to process the part from start to finish. In your operations, you're telling it stock is here, cutting is here, end here. You're physically doing the programming. NX is built right out of the box in such a fashion that you really should be letting the software just do everything for you. You should be letting adaptive roughing run for you, cavity milling, rest milling. You should be running feature-based manufacturing, and then you should be selecting those surfaces, right-clicking, and make a suggestion, tuning the suggestion up to where everybody has the same rules, everybody's creating the same holes, the same tooling, the same operations, same roughing strategies. So if you can, one thing that I tell customers when I'm on site is, if you have a group of 6 programmers, if I can walk out on the floor and ask one of the operators, do people have styles? Like if you just grabbed a program and you started looking through it, could you tell that one particular person programmed that? And every single time, yes, they say yes. Everybody has their own processes and their own procedures. That's 100% inefficient. We should be using the same procedures, the same tools, the same speeds, the same feeds, the same depth of cuts. If we find something better, we should change the system that then we implement on everything. Having people do their own things all over your shop makes it to where, one, you can't track quoting as opposed to part running, because this person ran it differently than the last person. So you've lost money on this run as opposed to the last run. There's a lot of different things that you lose by letting people have many different processes. Creating an environment where everybody just uses the same data and then updating it with new things, more efficient things, is the best practice principle of how NX was built to use. Okay, so now once you've developed your stage models, your realistic 3D representation or 3D digital twin of your process, then you can start to go through. So our digital thread, what we did is I started to process this. The automation suggested that it should be a 4-part process, 4-stage process. So then once I started looking at the automation, I said, no, this is actually a 3-part process, and we've refined it down to the concept B. So we have iterations in every single stage of our digital thread that we can pick and choose what is the most efficient. So we have analysis pieces. That's after it gets done processing our manufacturing plan, we can take a look at 3 different options and 3 different times and the analytics behind them and say, well, this is actually the most efficient way of going about it. So then once we go through and we physically create our stage models, there's one major thing that happens that causes great efficiency in a manufacturing environment. If I just have the model and then I have 3 programmers, typically companies just give the one part to the one person and they do the entire thing. That's because they have to wait until they're done programming the first operation to be able to know what to do on the second operation. Having a staged model representation, which is your manufacturing engineering plan, you can just kick it off to the entire programming department. Everybody can be working on up 1, 2, 3, 4, 5, whatever it may be, because you have direct representation. You can't do that unless you utilize 3D digital twin stage modeling. So we've created the digital twin environment, our stage models. We have kicked it down to the programming group. I have 3 programmers that are running all of the different programs at the same time. Once they're finished, we can deliver our programs as a group, a project group, but also we can do any type of variant to this, to where if there is some other lasers or water jets or additive manufacturing or anything like that, this is all managed and wrapped up into our project. So now going further with consumption of data. So I'm going to break at this point, go into my demonstration. So originally we had this model with our small corners, small ears. We did our FEA analysis, which provided this model. Now, stage modeling is much different than using wave geometry linking or anything of that nature. We would come up, it's physically located in the manufacturing module. So we go into manufacturing, stage modeling. This already has stage models to it, so it's just opening them. But this, what we're going to be doing is we're going to be defeaturing it. There's two ways, bottom up or top down. So we take the original model, and then now we can say, I would like to create one stage model. It's going to tell me I already have one, which is this. I took this part, I went into, and it's just the simple functions here, but you physically start with the associative part, and then you defeature from that point. You have full capability to use all of your standard modeling tools to add, remove, delete corner radiuses, unite things. That gave me my very first stage model. So now at this point, I have two different pieces. I have my original, and then I have my stage model. So now at any time, you're going to have different responsibilities. If I have this part, I can go directly into drafting and I can create all of my dimensions. But what are you going to do with that? So let's sit back and think about, what is a draft? We're in a day and age to where everything's digital. So what does a draft do for us? Or even what is a digital draft? What does it provide for us? Nothing more than a piece of paper that a person can look at and say, at the part, is this right? Is it beneficial? Sure. Is a piece of paper beneficial? No. But is digital? Yes, but to a small extent, just for you to visually check. The better methodology is to utilize PMI data. What is PMI data? Product manufacturing information. You're going to do exactly the same thing as you were going to do on the print. You can put all your GD&T, anything you want right here that is relative to the part. It's fully associative. You change the model, the dimensions change. But what is different between a draft and this? What I can do with this is, if I have a 10 finish on this hole or a 32 finish on this corner, that's going to push data into my CAM software to say, I can't just put a 125 roughing strategy to it or a 250 roughing strategy to it. If I put a H7 tolerance on this hole, it can't be just drilled. It's going to push information downstream so that my CAM software can choose different operations and different tooling. What does that also do for your CMM? Everything is based upon this part. NX works totally different than every other CAM software in this CAM and the CMM. Let's take Mastercam, for instance. If you're going to do a angled plane, just a 3+2 angled plane on a part, it's going to require ancillary and supporting data. You're going to have to create a plane that's relative to wherever your zero location is. And then in the operation, you're going to have to say tool, plane, operation is going to be done here. The post processor uses the plane to drive the tool's motion. NX doesn't need any of that information. It's 3D digitally aware. So if I were to just do something like create a new file and go directly into CMM, before I mess everything up, from folder, I'm going to create a new inspection file. I'll use this Wenzel's machine. So what NX does, as I said, it's 3D digitally aware. So what that means is this part is placed on a machine in a certain fashion. All of the PMI data that we've seen, it's in here. So all the PMI data that we've seen on there, that is relative to datums. So NX takes those datum points, the approach and the inspection vector that it needs to go. It knows that it has this motion, this motion, this motion, and 360-degree articulation, 180 degrees back and forth. So all it's going to do is it's going to say link to PMI, create everything using any stylus. That's loaded here. It's found the dimensions. It says, I understand everything, all of these functions, all of these features. It said I can do it in this fashion. Here are all the tolerances from my part. Now all I have to do is generate, run collision avoidance. And I haven't done anything to this, so I'm sure it's not going to be perfect, but you're going to get the gist of it. So in 2 seconds, if I wasn't explaining this, I would have at minimal 80% of my simulation, my program. And this also works 100% the same in NX-CAM, as long as you put forth the effort to modify the rules and the automatic suggestions that NX comes, and you build upon them to make them more and more complex. So this is just a small snippet of the automation capabilities that is capable with NX. So if you find yourself using the software exactly as you once did in a secondary or software, some third-party software like Mastercam, you really should think to yourself, you're only using the software 65% of its capabilities. The next thing is, you might need trained. That's a given. NX is not something that you just want to tackle yourself because of all the complexities to it. But once you do learn the basic format and how NX wants to see things and what is capable of being used, it repeats itself and becomes easy to understand and easy to do and propagate through different manufacturing principles. So this is exactly how the CAM product works as well. It's volume aware, and it articulates off of MCSs and then part and feature junctions. So now moving back to my stage model here. So let me see if I have a manufacturing program already wrote for this. Looks like I do. So as I was talking about, if we didn't have this direct representation of this part right here, we just had the physical part file in here, my very first operation, this 3D adaptive roughing, I just said do it. I don't have any type of geometries listed, no trim planes, no nothing. The reason you can confidently do that is because you set your program up correctly to have all of the different checked surfaces, which allows NX to think about everything. So I'm going to give you an example of how you should really drive yourself to start using the software like this. If I erase all of my operations, I'll leave the tooling there. This is indicative of setting things up correctly. Adaptive milling, I'll just choose a tool. You would predefine, and what you would do behind the scenes to be able to do this is, if you find settings that are repeating, you're going to want to change the out of the box template with NX, put it into a different folder, into the correct folder of NX. It's supposed to go in the update folder, and then utilize that. There's customer defaults and things in play now that are much different than NX12. So if you find yourself modifying templates, you should contact your reseller, contact us. We'll help you put them in the correct place so that they don't get overwritten the next time, or you don't have some convoluted network system going on. But we're capable of just attacking the part with NX's intelligence. Now, as I was saying about suggestions, NX is set up now to where you don't even have to run feature-based manufacturing like we traditionally did. Right click, find features, create feature process. All we have to do is change the filter, face, make a whole suggestion. It's going out and doing the same thing. It's finding features, except it's limited to holes. It's going out to the knowledge database right now. It's pairing tools with operations, looking at PMI data to say, is this just a drill? Is this just it said that my MCS isn't supporting this. Because I have it to set to Z. It says, I don't understand how I could possibly do that. If my Z axis is locked up to ZM, how am I supposed to hit that hole? Boom, got the hole. Now what if I wanted to remove this 3D adaptive? Now all I have is a hole. If I come back and do the same thing, say make a milling suggestion. It's going out, it's looking at databases. These are all standard databases. I haven't done anything to them. So obviously not perfect. I would just change it. Now if I wanted to come in here and do this face, so now what happens when it gives me wrong information? That's okay. I just go in there and change it. I go in and change my toolpath and my operations that it gives me, save the tools to the library, save the operation to the database, and then it's as simple as right click, make new suggestion, and then it will give me different levels of suggestions, priority numbers. You can set it from 999 to 1. Every time it sees a 1, it's going to choose it first. If for whatever reason you say this material properties are a little different than the last time, we got to go 80%, choose variant 2. We can get very intelligent with it. But just very quickly, you guys see the difference in how we should be programming comparison to how we are programming. So every one of my programmers, we're 8 strong now. It's a requirement that you first start feature-based manufacturing. Then you, if the suggestion isn't there, then you modify a suggestion and then you teach it to the library. I don't want people reinventing the wheel every time. I want people to have more time to look at new tools than to say, okay, does it work? If it does work, let's implement it into our broad system instead of, hey, I do this or I do that or I do that. It makes it to where you can then use this feature-based manufacturing as a quoting tool. You get to where you're 90% efficient. You can right click, find features, right click, create feature process. It'll give you a bill of material. It'll give you suggestions on machine tools. Does it need 4-axis, 5-axis, 3-axis? From a quoting standpoint, somebody who doesn't know manufacturing at all, they can do these 5 clicks and give you about a 90% accurate quote. So it has implications for all the way down, all the way from top to bottom, downstream and upstream. So this is running through our digital thread. Now we have this done. Now what happens with our machine tool? We would reach out to a library. We would say this is the machine that it has to go on. But all of this is unmanaged. So what happens if I changed up the post processor to do something I like? Or what if this guy did something and destroyed his post processor and now it's not accurate? This is a big problem with an unmanaged system. So now that we have the machine tool, we've created our digital twin, we can start to utilize all of the capabilities within X all the way through to the simulation, the quality. I've shown basically the entire process start to finish of how we would process the digital thread. But a lot of things that you're seeing that you don't typically see is things like the stage modeling, the PMI data. So if you just do a few things, if you just start processing your parts like the software wants to, one of the complaints that I get from customers is we only manufacture parts, we're not a design house. I'm like, oh, okay. Do you make your own fixtures? Well, sure, we do it in SolidWorks. Okay. Do you check those fixtures? Yes, we do it in Calypso. Okay. Just because you're not designing the parts doesn't mean that you shouldn't have a robust design department that at minimal can process manufacturing engineering. So there should, the right process would be you have your design group, your manufacturing engineering group, your CAM group, your CMM group. Everybody is talking the same information, but it's all being pushed by your design group. So if I get a part that a customer sends me in Creo and says, I need you to manufacture this, first thing I do, it doesn't matter how much ancillary data they give me. First thing I do is turn it into an NX part. Second thing I do is open their print and copy their dimensions into PMI data. That's the very first thing before it gets processed at all. Is it extra work? Nope, it's reallocation of work. It's just you're doing things in a different manner. And once you have it done one time, it's going to create magnitudes of efficiency. You just reuse this stuff over and over and over again. So let me get, and as I said in the beginning, there's a lot of information here. So I know we're a little over time already, but I want to get through the demonstration or the presentation and then get on to the questions and answers. But I would encourage everybody to join next sessions. I'm going to be showing what does Team Center look like today. Many of us have used Team Center in the past in the rich client format, and I'm with you. I wasn't an advocate. I didn't necessarily like it. I felt it added more work to our workload. But the way that they have a Team Center set up now, it's very fluid. It's a really easy tool. It works off of an active workspace window, which is very familiar in many different softwares. But they've created these very quick, easy dashboards to where you can have a lot of data on just a click of a button, and you can see entire setups and fixtures and get bill of materials for everything. It's very, very, very nice. So I did show you the digital thread quality piece where we use the CMM, the PMI data to process automatically through the CMM. All we would have had done to continue that was to create the documentation. But the point is that it was consumed. Now, the last piece of this is what happens when we get a revision change? That's the point. That's the whole reason why NX is super expensive, but super powerful. Because if we get a revision change, we simply come to our initial place and we just replace a component. I don't have a replace component for this, but the replace component works nonetheless. So if this is the part that I'm replacing, I would just replace the component, but this is non-managed, of course. I'd find my component, I did hit OK. It's going to put it right in the exact place. The most important thing is all surfaces are relative to the previous surfaces. So there's no catching up the toolpath. It'll all go out of date and you just hit generate. Same with the CMM inspection. You just replace the component. So I'll replace this component with the base link. Just so that you can get an idea. So I just replaced the component. Now I'd have to do just the smallest amount of adjustments. Rerun my link. Reprocess my program. Reprocess the collision avoidance. This may take a little bit more time than I want, but you understand the point. All we're doing is just reprocessing the existing. It gets much different when we're in a managed environment because everything is checked in and out, and you're working in a much different environment. There's a lot of things that I didn't show you here, which is going out and finding these files, assembly load options failing, and you having to search in File Explorer to find things. It can get very, very time consuming to orchestrate a non-managed environment and not fail, not have misruns or things of that nature. So it's going to show a much better environment, much more efficient to process components. And I would recommend that if anybody has any questions or interest in the Saratech digital thread or a digital thread per se, specifically, to reach out. And I think that we're probably leader in industry when it comes to truly having a digital thread. We have multiple digital threads, data management, drafting. We have multiple highly efficient processes that we can process some of the work that you guys currently do.
Thank you everyone for being here with us. We'll see you next time where Mark's going to be showcasing the managed environment. Thank you so much for joining us today.